We're finally going to be wrapping things up for this lecture module, and I told you that in this video we're going to be focused on the nomenclature of the ring systems. And here's an example of what I'm getting ready to talk about. So here, if I'm given this molecule the way that it's drawn on the sheet of paper, notice that I have no really idea of how these methyl groups are oriented. So because I have no idea of the orientation, I would give you a name that looks something like this, right? Here's the cyclopentane ring. So cyclopentane's here at the end. And then at carbon number 1 and at carbon number 2, I have two methyl groups. So 1,2-dimethyl cyclopentane. And that is really how we have provided these names over and over and over for video after video after video. All right? And that's again because I have no clue, no idea of the direction or the orientation of those methyl groups. That is why we do this. Okay, so that would be a correct answer for this particular type of question. However, what they could do to me is they could somewhat draw this cyclopentane on its side. And I'm only going to draw part of it. Okay, so just imagine that this is a cyclopentane and not a cyclopropane. So just a part of it. And they're going to shade me a really deep line here in the beginning. And they'll have maybe a hydrogen pointed up and a hydrogen pointed up, and maybe a methyl group that's pointed down and a methyl group that's pointed down. Well, this gives me an idea of the orientation of the methyl groups. So if this was truly cyclopentane, and I can maybe make that change. There you go. If that was truly cyclopentane, these two methyl groups are pointed in the same direction. They're both on the back side or the underside of that ring structure, right? So what they want me to do in this case, because they took the trouble in drawing me the structure that way, because they've done that, and it was an ordeal for them to do it, right? It's not a very easy process to draw it that way. But because they took the trouble and effort into drawing it that way, they want me to take the trouble and the effort to naming it the proper way. Give me the details that they put into the structure. So because these are pointed in the same direction, this would be called a cis. And this would be a cis 1,2-dimethyl cyclopentane. Notice that the cis goes in front of the name and we hyphenate it. So cis is letting me know that these two groups, the 1 and 2 position, those methyl groups, are on the same direction. We call this a geometric isomer. And you can kind of see why. It's all about geometry. It's all about the 3D shape. It's all about which way these bonds and stuff are pointed. So on this side, if I drew that really dark line here in the beginning, and I go out and make this a cyclopentane ring, and then they tell me, hey, one of these bonds points up, one of these points down, and one of these point up, and one of these point down. They are wanting me to bring the detail that they brought in the structure. I now have an idea of the orientation of those methyl groups. They are pointed in opposite directions. Even though this is not a cyclohexane ring, it's a cyclopentane ring, it doesn't matter. They're pointed in opposite directions. So because of that, we're going to call this a trans 1,2-dimethyl cyclopentane. And that is how we write the name, the IUPAC name of that particular structure. So all this time, especially when we've been drawing these rings, we actually could have went a little bit more detailed and put cis or trans in front, but we did not. Because at that point, we had no clue what the orientation was. I can't get the orientation from something like this. They just want me to give me just a blando name. 1,2-dimethyl cyclopentane and call it a day and move on to the next problem. But if they begin to start drawing these structures on the side, like they've done here, with these dark wedged kind of sideline ring structures, then they want me to take the extra time to go in and really draw them and name them the proper way. Now, this is not the only way that we can draw and represent these structures. As you can imagine, no one really wants to go through this trouble, do they? No, they don't. So the other thing that can happen is that they can take a structure like they started with up there in the top center. And another way that they can do this is bring in what we call a solid and a dashed wedge. All right, so here I'm going to do a solid wedge, and here I'm going to do a solid wedge. I'm going to shade them in. Super black. There you go. Well, because both of those are shaded the same way, this means that they are pointed in the same direction. That is the representation of a solid or a dashed wedge. So both of these are solid wedges, which means they are both pointed in the same direction. The solid wedge typically means pointed towards you. That will come much more important later on down the road, but here is our first encounter of a solid wedge. So both of these are pointed toward me. They're both pointed in the same direction, and because they're both pointed in the same direction, then this is going to be called a cis 1,2-dimethylcyclopentane. It's just another way for them to draw that bond a different way that maybe saves them a little bit of trouble. All right. The other version that you might see here is a wedge, and instead of solid, it will be dashed. All right. So here we'll see some dashed lines in that wedge. What that means is that it's pointed away from you. So it goes away from your face. It's pointed on the back side. That is what that notation represents. So again, both of these are on a dashed wedge. That means both of them point away from you in the same direction. And because both of them are pointed in the same direction, that still is a cis molecule because they are pointed on the same side. All right, so finally, we can take these bonds, and I could maybe do one of them as a dashed wedge, and I can do the other one of them as a solid wedge. And this is a notation that we use when they are in opposite directions. So this one is pointed away, this one is pointed toward me, and because they are pointed in opposite directions, this is going to be representation of a trans molecule, and in this case a trans 1,2-dimethylcyclopentane. So it's just a way for us to quickly kind of give you a little bit of detail about the direction of the groups, and that's through the use of a solid and a dashed wedge, and that's why we have them the way that they are. All right, so that's why we do it, and that's how we handle it in an organic chemistry class. All right, so here's another one. Let's name these two things. The one to the left we kind of already named already. It's just looking at the structure from the side. So this is a cyclopropane ring, isn't it? So this is cyclopropane, and it looks like on carbon number 1 and carbon number 2 I've got groups. That's a methyl group here and a methyl group there. So this is a 1,2-dimethyl cyclopropane all on one line. I had to break it up here. And they're pointed in opposite directions. This methyl group is pointed down. This methyl group is pointed up. This is not the solid and dashed wedge orientation. I'm looking at it from the side, right? I see that really dark bolded right here, and it looks like three-dimensional wise that piece is further away from me. So because of that, this is pointed down, that is pointed up, and this is a trans orientation. So trans 1,2-dimethyl cyclopropane. Here on the right-hand side, we'll do this one as well. Again, this is looking from the side, and it looks like I'm looking from the side of a six-membered ring. So this is a cyclohexane. And if I look at this, I've got a group that's going to be here, and I also have a group that's going to be here. This group is called a methyl group, and this group is going to be our tert-butyl group, right? There's no really preference in alkyl groups. The tert-butyl group and the methyl group, as far as the numbering goes, should I give the 1 position to methyl or the 1 position to tert-butyl? It really doesn't matter as far as that goes, but I'm getting ready to list them in alphabetical order, and because of that, the B comes before M, and by default, I would just give this one a 1 and this one a group number 4. If you don't do that, I still probably will give you credit for it. I won't take off for that. Blackboard might, but I won't. All right, so on position number 1, I have a tert-butyl group. So 1 tert-butyl. And then carbon number 4, I have a methyl group. And then I have cyclohexane. But they've drawn the shape to look at the side, to look at orientation. This one's pointed up. This one's also pointed up. And because of that, they're both in the same direction. So this would be cis. So this is a cis, 1 tert-butyl, 4 methyl, cyclohexane. All right, next one. Here's a problem. Is each of the following a cis or a trans? All right, so they don't want me to name them, but I'm going to. They just want me to look at cis or trans, and that's what we'll do first. All right, so if I take a look at A, this bromine is slightly pointed down, and this chlorine is slightly pointed down. Well, both of these are down, so that means this is cis. All right, so for part B, this bromine's pointed up, and this methyl group is slightly pointed up. They're both in the up direction, so therefore this is going to be the cis. For part C, this methyl group is slightly pointed down. That means this one would slightly point up, and that means that that one is actually slightly pointed down. So just in case you had confusion on the direction of that bond, that's the way that you can do it. It always alternates. So this is down, and this one would be up, and this one would be down. This one's slightly down, that one's slightly down, so therefore that is the cis notation. They're pointed in the same direction, right? Next one, D. I have this bromine group. This bromine is slightly pointed down. I can see that there. And then here, this methyl group is slightly pointed up. All right, so these are opposite directions now, right? Slightly down, slightly up. So this would be the trans orientation. For part E, my chlorine is slightly down, and this methyl group is slightly up. I'm comparing those two different groups. So one slightly down, one slightly up. This is going to be the trans notation. And then for part F, this methyl group points straight up, and then this methyl group points slightly out and down. So one is down and one is up, which means that this is also the trans. So it just so happens that the 3 on the left are cis, and the 3 on the right are trans. Now, I told you I'm going to go through and name them, just to give you more practice about nomenclature. So keep in mind that the cis's and the trans go in front. So now we need to come up with the rest of the name. All right, so what's the rest of the name here? Well, here's a cyclohexane ring. All right, so cyclohexane, and they're all actually cyclohexane rings. And then here on carbon 1 and carbon 3, 1 and 3, I've got these groups. Well, they're both alkyl groups. One doesn't take preference over the other. I just really do this in terms of alphabetizing. So I'm going to give this one a 1 because B comes before. So 1 bromo, 3 chloro, cyclohexane, and then I would really want to put cis out here in front. Now, I'll put a hyphen here. That hyphen probably should not be there. It needs to be squeezed in a little bit to make this one word. But there was some empty space and it bothered me, so that's what I did. Again, no big deal. I'm not that picky. All right, for part B, we know it's cis, but we got to name it. All right, so here we have a bromo group, and here we have a methyl group. The issue here, though, is that bromo is a little bit different than an alkyl group. Alkyl groups are kind of normal, run-of-the-mill, same-o, boring, right? Bromo spiced it up a little bit. So I'm going to probably give this one a group number 1, and then 2, 3, 4. Or if I go the other way, if that's a 1, then this is number 2, then that's number 3, then this one's number 4. It's a 4 no matter how you go with it. And then I put everything else in alphabetical order. So this has to be a cis, 1 bromo, 4 methyl, cyclohexane. And that's the name for that structure. The next one for part C, we know has to start off with cis. We already determined that. Again, bromo is going to get a preference here. This is carbon number 1, carbon number 2, carbon number 3, lower group numbers. Right, there we go. So this is a cis 1 bromo, 3 methyl, cyclohexane. And there's your foreign language for the day. All right, so for D, E, and F, same deal, but now they're trans. So I'm going to start this off with a trans. I give bromo group number 1 as a preference just because it's a little different like usual. So on carbon number 1, I have a bromo group. And then on carbon number 2, I have a methyl group. And that is on a cyclohexane ring. So trans 1 bromo 2 methyl cyclohexane. For part E, do the same thing. Trans. Here's a chloro group and a methyl group. I'm probably going to number closest to my halogen. There's number 1. So this is 1 chloro. This is 2, 3, 4. And the other way is 2, 3, 4. It's going to get a 4 no matter what. So 4 methyl cyclohexane. For part F, I see a trans. There we go. And here I am comparing 2 methyl groups with each other, so one does not take any priority over the other. So I'm just going to randomly start with a 1 here on one of them, so I'm just going to put that one as my first. Then on carbon 2 and on carbon 3, that way it gets a lower group number. So this is going to be a trans, and this is going to be a 1,3 dimethyl cyclohexane. And there you go. So we did an extra part of this problem, but I thought it was good for you. It reviewed some of the nomenclature rules. It kind of started wrapping things together that we've been learning. And there's you some examples about cis, trans, and naming ring structures. And really just basics of naming altogether, right? All right, so another example. Here's our last one. It says, draw the more stable chair conformer of cis 1-ethyl 2-methyl cyclohexane, and then B and C is going to be something similar. Okay, so I'm going to go through, and I'm going to tackle these one at a time, and I'm going to take my time with these, because this is the problem that people have. Okay, so for part A, I have 2-methyl cyclohexane. All right, so the stable chair conformer, it tells me that right there, chair. So that means they want me to draw this thing in a chair. So I'm going to have to come over here to the side and point 1 up and point 1 down, kind of like this right here. All right, so here is my cyclohexane ring in a chair. The back side and the foot side. And there's the seat, the flat part. Well, on carbon number 1, I have an ethyl group. All right, so I'm just going to draw this straight up. Bing, right there it is. CH2, CH3. And then on carbon number 2, I have a methyl group. All right, so there we go. So I just randomly put them on here just so I have some bearing of where we need to start. That's all that I've done that for. That's it. So on one carbon, I have an ethyl group, and on the other carbon, I have a methyl group. Now, it says the more stable conformer, doesn't it? And I've told you all along that the larger groups prefer equatorial. And right now, the way that I've drawn this, my larger group, which is the ethyl group, is in the axial position. I don't need it this way. So I'm going to have to come through and I'm going to erase this because I know that if they want stable, that's not going to be stable for it. So with this axial bond points straight up, and that means that this equatorial bond points slightly down. And this is where my CH2, CH3 is going to be. It's going to be on that equatorial position. Now, I've got to worry about my methyl group, okay? So, because we're focused in on the most stable conformer, I have to remember, if this axial points straight up, this axial points straight down. If this equatorial goes slightly down, then this equatorial has to go slightly up. They're kind of opposite. They've always been that way. The reason I'm doing this is because I'm going to have to put a methyl group in. But I have to make sure that I put it in on the cis location. And right now, this ethyl group is slightly pointed down. That was my biggest concern. That was the biggest group. It's slightly pointed down. So on this carbon, this down position, which is axial here, has to get my methyl group for that reason, because it needs to be cis. They need to be pointed in the same direction. And if I drew the CH3 equatorial here, this would go slightly up, that would go slightly down. And folks, that's a trans. That's not the cis notation. And that's actually what B wants here. All right, so B is going to say, draw the more stable chair conformer for the same molecule, but this time the trans form. All right, so how would I answer that one from scratch? Well, we do it again. All right, no big deal. I can say the same thing again. What do you think I do all day? It's not going to hurt me, and it might be good for you to listen to it again too, right? No big deal. I'm not bothered by it. So here's my cyclohexane ring, pointed straight up, straight down. There's my backing, and there's my foot, and there's my seat. So on carbon number 1, I would say, hey, we've got this ethyl group, right? 1 ethyl. And then on carbon number 2, I have this methyl group. That's what it tells me there. But this time, I've got to worry with trans. All right, so what I would do is I would look at this and say, most stable, most stable. And I would look at this ethyl group and realize that it's bigger. So because of that, I need to draw that group in an equatorial position. So again, straight up is axial, and slightly down is going to be my equatorial. So my equatorial is CH2, CH3. That is going to be the most preferred location of that particular group. All right, now on my neighboring carbon, again, I do the same thing. If this axial is straight up, this would be straight down. And if this is slightly down, then this needs to be slightly up. So there is the orientation of those particular axial and equatorials. And I need to figure out where my CH3 goes. Well, this is trans. So if I look at my ethyl group, this is pointed down. On this one, I need to be choosing the one that points up. And that's the equatorial position right there. So this is where my methyl group needs to go in that location. So slightly down, slightly up, opposite directions, that is my trans. Now, I want to go back and talk about other things about A and B before I go on. And the reason is because what do I do with these other bonds? I can't just leave them out here like this because that would be understood to be a carbon. So some people will write the hydrogens on these things just to cap them off. So that way, if they do draw both of them, then they can clearly show the directions of them, the axials and the equatorials, and that's great. And if you want to leave both of them on there, no big deal. But you have to put hydrogens there. Otherwise, someone would assume that this ending stops, and that ending would represent a carbon, because that's what skeletal structures mean. And you just got to be careful, right? So if you're going to leave both of them, at least draw the hydrogens on there, so that way you can kind of tell which one's which. But if you don't want to be bothered with the hydrogens, then folks, my advice is to go back and erase that bond that you did not use. All right, erase that hydrogen and erase that bond that you did not use. This ethyl group is still slightly pointed down, and this methyl group is still pointed straight down. It's still cis. I can still see that from the structure. I don't need those hydrogens in order to see it. If it helps you see it, write them. I'm not going to take off with them, and I'm not going to get mad on it. So over here to the right-hand side, right, this is slightly down, this is slightly up. That's all that I need to see. If you want to write the hydrogens on there and cap them off and make it more full of a structure, then so be it. No one's telling you that you can't do that. But for me, I just don't want to be bothered with all the extra stuff if I'm not going to be doing anything with it. So I get rid of them. So I still see that this is pointed slightly down and that one's pointed slightly up, and they're in opposite directions, and it's still a trans notation. And that's all that the problem wants. If you can tell that, I can tell it too. But if you want to draw those hydrogens, draw them. Be my guest. Do all that you want to do with them. All right, so for C, which compound's more stable? The cis 1-ethyl 2-methyl cyclohexane, or the trans 1-ethyl 2-methyl cyclohexane? Okay, so what they've done now for part C is that they want me to compare these two. And they want me to think about which one is the more stable between these two structures. That's what it says. Cis 1-ethyl 2-methyl cyclohexane. That's what we drew in part A. And then for part B, trans 1-ethyl 2-methyl cyclohexane. That's what we did in part B. So they want me to look at these and say which one is going to be the more stable one out of the two. All right, well, if I take a look at the one to the left, my largest group, the way that I've drawn this, is equatorial. And that's good. That's what it needs to be. But over here on the right-hand side, my largest group is also equatorial. By default, I draw them that way because that's what A and B told me to do. It told me to draw the most stable one out of the bunch, right? I mean, that's what it said. Okay, so I can't use that as a guideline. I can't use that as a judge. I need to look at my other groups. This methyl group has an axial bond, and this methyl group has an equatorial bond. Because both of these are equatorial, that gives this ring more stability over the other one. My methyl group, it's still a group. It's not my largest group by all means, but it's still a group. And rings really like it when their groups are equatorial. And the more they can become equatorial, the more stable that those rings will become. And that is why this structure is going to be more stable than the one to the left. This one has an axial bond. That axial bond gives this ring structure some problems later down the road because, again, it's a white flag that says, I surrender, come and get me. And that's what these reagents will do. And it lowers the stability of that particular type of compound. The one to the right-hand side, this one, it's got equatorials for both of these groups. And this ring is a very satisfied, happy ring. Just like you are a very happy, satisfied person right now, because this is the last video, and I am very happy and satisfied that I don't have to do any more videos for this lecture module. I think we've had enough. I think there's been so many different lecture topics that have been presented. That's the way that this chapter is structured. We did a little bit of a naming. We did a little bit of organic nomenclature, organic structures. We brought in functional groups of alcohols and amines, alkyl halides, ethers. We named all of those. We IUPAC'd them. We common named them. We've talked about isomers of cis and trans. We've talked about ring structures and conformers and staggereds and eclipsed. Just think about all of the stuff that we have discussed in this particular lecture. Tons of material. But folks, they just dumped us into the water and they expected us to swim. And I hope that I've given you a few life preservers to help you until you get ready to swim in the organic lecture theory. And this is a start. All right. So take my life preservers from this lecture module, go back and brush up on the things that you didn't quite fully understand the first time around. Take a look at the example problems that we're doing in Blackboard. And then if I give you the homework assignments, go back and take a look at those homework assignments and think about really, truly, if you fully understand them. I will tell you, don't use Google. That's going to be a problem for you. If you use Google or a search engine to try to answer these questions, you might be able to find the answers. But that's not going to help you on a test, and that's also not going to help you too much if I give you the structure and I ask for the name, right? Because how are you going to input this into Google? What are you going to do, right? You're going to get crafty and you're going to take the trouble of do some kind of image search on crap. I mean, it's just a waste of time. So you're going to have to understand the basics of this organic in order to get through it. And that's where the problem is going to lie. It's very easy for you to type in a name and give me the structure. That can be Googled all day long. Whatever. I know that. I'm not stupid, right? I was a student too at one point. So if I give you structures, and that's my preferred way of doing it, and I say, what is the name of this structure? That's a little bit harder to search. It's a little bit harder to find. And you really do have to use the rules of organic in order to answer those questions, and not the rules of a Google or a Yahoo or a Wikipedia in order to answer those questions for you. All right, so that's where this video is going to stop. It's also where this lecture module is going to stop. We are finished. So go celebrate, finish out the rest of these assignments, and then just make notes of this stuff, because you know good and well a lot of this is going to be on the first test, and it really does hold hand in hand with the next lecture module that we're going to be talking about. And that next lecture module is going to be a group of compounds that we call alkenes, not alkanes. But you're going to see the rules are going to be very similar. So I think that they mesh very well, which is why I don't feel bad about slamming another lecture module on top of this one that's already a full plate.